Hi everyone, I hope you're good. In this video, I just want to do a quick explanation of some of the things in the memo in case there were things you were uncertain of. This is a question from a past paper from a few years ago, so let's just go through the solution that I prepared for you. Okay, so the first thing you're going to do is load your data set. I called it data, and then I printed the first column. So you can see there are 5 columns, and the last one is called letter grade, and it contains characters. So obviously you can't put this into your logistic regression model. This needs to be converted to a dummy variable. Now, fortunately, it's already been done for you in the grades column. So you see in the question paper, it said y is equal to 1 if the final mark is an A, and y is equal to 0 if it's a B or a C. So you'll see now, whenever you have a B or a C, you have zeros, and when you have an A, it's equal to 1. So all you need to do now is just drop this column before you put it into the model. So that's what I've done here. There are different ways of doing it. I chose to just select the first 4 columns, but you can Google to how to drop a column. And then notice here, the original data is stored in data, and then I have now stored the required columns in a variable called grades. Okay, I didn't want to overwrite data, so that's why I copied it into grades with those required columns. And now you can see when you print the data, you only have the 4 columns. Okay, so now, when you put this data into the logistic regression model, notice here that you have some categorical variables, specifically your y, which is now your final mark, and then you'll also have psi. Psi is the new teaching method, whether the new teaching method was used or not. So 1 if it was used, and 0 if it wasn't used. So in both of these cases, having a value between like a number like zero point 0.5 or 0.75, it doesn't make sense. These are categorical variables. So we need to make sure that R knows this. So when I first check in the current state, if you check what type of variable this grade column is, so grade is your Y, you'll see that it's numeric, and then also psi is numeric. You need to convert it to a factor. So that's what happens in the next few lines. We convert it to factors, and with the levels equal to 0 to 1. I'm noticing here I didn't include that, but it's going to work. So now you have these two factor variables now. So we can now construct the logistic regression model. So remember, you're going to use GLM, and then here we want to use all the columns, and then you need to give it the data set. So remember, it's stored in grades for me. And then since we're doing a logistic regression, we've specified the family as being binomial. And then if you print now a summary of what's stored in grades.logistic1, then these are the results that you get. And then it says in the question, though, to construct the model where you're using only statistically significant um, variables or predictors. So in this case here, you can see that the ones which have this symbol, the 2 stars and the 1 star, these are all values that are between 0.01 and 0.05. So remember I said wherever the star or the symbol is, this is the lower bound and this is the upper bound. And similarly here. So in order for a variable to be statistically significant, then it needs to be below, have a p-value below some sort of alpha. So in this case, we're going to assume that alpha is equal to 0.05. So anything that is below 0.05 is going to be considered statistically significant. In a test or an exam, I would specify what it is. We're going to assume here it's 5%, which is 0.05. That means everything that has a star or 2 stars or 3 stars is going to be statistically significant. And in this case, that's everything except for this TUCE predictor. So we're going to drop predictor and reconstruct the model. So in order to do that, you will now rewrite that same code here, but now your change is going to be here. So one way of doing it, you could have said grade and then this tilde, and then you would have said GPA plus psi. You don't need the 1. Remember, there's no psi 1. It added 1 in the GLM in order to just identify that that is for when psi is equal to 1. Um, okay, so here you will have grade plus GPA plus psi, or alternatively, you can still use the dot notation, but then you put a minus TUCE. And then that's going to give you now the new model where you only have GPA and psi in the model. And you'll see now everything is statistically significant. So in terms of this question, the best model is going to be the one where everything is statistically significant. And then you have to provide the final model, and it's going to look like this. So remember, the general formula for a logistic regression model is this linear combination. So it's a linear equation equal to the log of the odds. Okay, so this whole thing inside is your law, is your odds, and then notice everything has a hat on it because it's estimated from your data. So if we get the values from the model, beta hat 0 is minus 11.602, so you put it in there, and that gives you that value. And then 3.063 is your beta hat 1, corresponds to your coefficient for GPA, and then 2.336 is a coefficient for psi. So this is going to be the final model. And then from here, if we wanted to now do the calculations here where you estimate the probability of a student getting an A, that in other words, the probability that y is equal to 1 given now specific data. So in this case, GPA equals to 3, TUCE equals 24, and that the student had the new teaching model, then you'll be able to, now you need to plug this into your formula and calculate it. So the easiest way to go about it is to just calculate it manually. So if you rearrange this, making this probability y hat equal to 1, the probability of y equal to 1, make it the subject of the equation. So you rearrange this whole equation, you will get a formula that looks like this. So you'll end up with e to the power of that thing divided by 1 plus e to the power of the same thing. And that's equivalent to having p equal to the odds over 1 plus the odds. So this is the formula you're going to use to calculate your probability. And in the next lines, you just plug in the values as they were given. Um, so the way you'll do it in R is to type out the equation. So exp does your exponent, that's e to the power of something. So e to the power of this is what you put inside your brackets here. And then you'll just need to remember to use a times sign because this is not going to work as is. R needs to have it specifically specified that it's multiplication. You'll get an error if you only write this. So what I have here is just this formula now typed out in terms of your R code. And then when you print the result, you get 0,481258, which was just rounded off here. And then similarly, you'll do the same thing for P. And then notice here, they specifically wanted GPA equal to 3, TUC equal to 24, and then your new teaching model used. So when your new teaching model is used, that means psi is equal to 1. So remember they said you must use the final model. So the final model, notice we dropped TUCE. So you're only going to substitute 3 and the value of 1 for the first probability. So where you have GPA, that's here, you put a 3. Okay, so remember the coefficient was at 3.0603. So you'll have times 3. And then we had the teaching method is equal to 1. So therefore, that's how you'll plug it into your equation. And then the second one, you have 1.9, and the old teaching method is 0 if it's not used, if the new teaching method is not used. Okay, new teaching is 1, not new teaching is 0. So that's the old one. So you'll plug in the 1.9 um, 1.9 for GPA. I can see here there is a small error. I'll update it in the final version. So it's supposed to be 1.9 times 3.063 plus 2.38 times 0 because we didn't use the new method. And that'll give you this result. So this will be correct in your version. Okay, so that's how you get the probabilities, and then if you wanted to now classify whether the person got an A or a B, then you'd use a threshold. And if it's above that threshold, you classify the person as having gotten an A. So in both cases, both values are less than zero point 0.5. So if your cutoff is zero point 0.5, then you'd say in both scenarios, the students didn't get an A, they got a B or a C. Okay, and then lastly, you're supposed to now plot the graph. They said for the grades dataset, fit a simple linear regression model to the data using the LM function. So you're going to have to Google this to see how you do it, but it's very simple, similar to your GLM function. So almost like your GLM function, you specify the model. In this case, I used all of the variables. I did what's called a multiple linear regression because we're using multiple variables. So it's not just um, the GPA, it's the grade, and I used the G2, TUCE, and Psi as well. So some of you imagine in this question it wasn't as clear whether you should use all of them or not. It doesn't say multiple linear regression. So if you had used just GPA, then your code would have looked like this. If this question was being presented in an exam, if I were setting it up, I would make it clear. So don't worry if you used the other one. Okay, so the difference now between your linear regression model compared to your logistic is in your formula, instead of having log of the log odds is equal to this, you actually have y equal to beta hat 0 plus beta hat 1 x1 plus beta hat 2 x2 plus beta hat 3 x3. Okay, and I stopped at 3 because I have 3 predictors, but it's as many as you have. So that's the only difference if you use a linear regression. Instead of the log odds equal to this, you have y equal to this. So that's what's happening in the linear modeling part here. You specify your data, and then you don't have to add that other line here where you have the family because it knows it's doing linear modeling. That's all. So the only thing you do is you give it the model, grade tilde, your predictors, and then your data set. And then if you print the results, you will get the results for a linear model. So this model actually is going to look like this. So it's saying y equals minus 1.49 plus 0.46 GPA, and then plus 0.01 times TUCE plus 0.37 times your psi. Okay, so it would actually be y hat. So I'm just gonna, you'd have a hat if you're writing it mathematically. I can't do it here. So this is actually the model that's being calculated in this part here. And once again, you can see that TUCE is not statistically significant. So if you wanted to use only the significant ones, you just drop TUCE, and then your model would not contain that part, but you'll probably have different coefficients. So this is the model, and then they say that now they want you to plot grade versus GPA. You wouldn't be able to plot this because there's too many dimensions because you'd have GPA, TUCE, and Psi. You'd need an axis for all of those. So you wouldn't be able to plot it on a graph with X and Y. So what you will do in this case is just plot Y hat, which is your GPA, your grade, equal to minus 1.49 times just this part here because they only want your grade versus GPA. So this is what the graph is supposed to look like. So let's quickly just go to R so I can just show you. So I've already run all the code. This is exactly what's in the memo. And then this is the way you're going to use the plot function. So you're going to need to have Googled this. And then you specifically tell it what um, the model is that you want it to plot. So it's grade versus GPA. And then we tell it the data set. So notice here I've got grades 2. And the reason I have grades 2 is because I copied the data set again. So remember it's stored in data. And I converted everything in the grades. Remember, you had factors, um, and you will get an error if you try to give factors to the code later on in question 3. So that's why I just recopied the data, but I called it grades 2. So everything is in its original format. So if I just print everything in grades 2, you'll see everything is back to none of them are factors, they're all just numeric. And that's what I gave to my linear model that grades 2 because it gives me an error if we try to use the data as in the with the factors. So remember the one here, grades, has the factors we converted. And when you run that with the factors, it says it can't deal with factors. So everything has to be numeric. So that's why I recopied it without the conversion, and then that's how you'll get the results that we have now. And then for the plotting, back to that, okay, so you have the model, you give it the data, and then the other arguments that I gave it is the bounds for the x-axis and the y-axis. So the x-axis is going to run from 1 to 5.5. So this is, let's run it, that part alone. It'll give you 1 to 5.5. And then for the y-axis, it goes from minus 0.5 to 1.5 as specified in here. So that just gives you the data plotted. And then what R does is now if you want to add the line, you need to add um, another line of code. It's going to build on top of the plot that you already have. And if you Google how to do a straight line in R, you'll find it's the AB line function. So A actually represents, you'll see here, you specify A, B, and then there's other things. So the easiest way to just figure out what goes where is to use the help function. So you do a question mark and then a B line. When I run this, it's going to show me the help. So there's a whole bunch of things that go in here, but the first thing that it's going to take is A, which is your intercept, and B, which is your slope. So that's what I gave it in this line here. So if I print, let's start off by printing everything. This is my model, grades.lm. So grades.lm, if you just print that, it's going to give you that model that I wrote for you earlier. It gives you everything. It gives you basically this model. So, but remember, it only needs A and B. So in order to access the coefficients, because remember it's got all of this data. It's got the call part, it's got the coefficients. If you take only what's in coefficients, okay, so I just said coefficients, dollar sign coefficients, then it gives you just the intercept and the other coefficients. And then I only want this part and that part. So I specified that I wanted columns 1 and 2. Yeah. So if you write that, that gives you A, the intercept, and B, the slope. So that's what I gave it in here. Though you could have specified A is equal to that, B is equal to that. It would have done the same thing, because that's another way you could have done it. And now if we go back to our plot, okay, Now we run the AB line part. It's going to draw the line there. Okay, I'm going to remove that. We don't need that. The other arguments here, I tell you the color. I specified that I wanted red. And then this argument specifies the line thickness. So you can play around with those variables to see what else you can do. And then, as I mentioned earlier, the question didn't necessarily specify whether you wanted to do a linear regression where you only use grades and GPA or use all of them. So I also did a version where I only did the two. So if you change that grades, I call it grades LM2, the first one's grades LM, then here the model is grade GPA with the same data, and you can run that code and you get the summary, but now you only have a coefficient for GPA, and then you can do the same plotting, but this time it's grade versus GPA. Here we had um, oh yeah, it's the same actually. Everything is the same. The only difference is that now when we add the vertical line, since the slope and the intercept are different to in this case, I only have grades LM2. You can just print what's in there. Yeah, intercept and slope. So if I run this code, you'll see the line shifted a bit. Lastly, if we just look at the interpretation, because it says comment on the R squared and then give a short explanation. You'll see here in the memo, you only have 42% of the variation in grade explained by GPA when you use this line here. And where you get that value from, it's this multiple R squared. It's a multiple R squared is because you have multiple predictors. So this 0,4159 is your R squared. And remember, R squared is just your coefficient of determination. It tells you the proportion of the variation that is explained by the model. So in this case, it's 42%. And then remember your logistic regression line is usually going to be an S-shaped curve like this, giving you values between 0 and 1. But when you put the straight line through the data, you see now if you give it a value like 2.5, it can predict something that is negative. Or if you give it a value of a GPA that's 5.5, it'll predict a probability that's greater than 1. So that's why the linear regression model is not appropriate because it can give you values that are outside of the range. And then lastly, if you had used a version where you only do your linear regression model using GPA and then you plotted the graph, remember this was the alternative, then you would have gotten an R squared. They just say multiple R squared, whether it's multiple or not, but it's just R squared. Here you see it's only 24% of the variation that is explained by GPA in this linear model, which is actually a little bit worse than before when it was 42%. And once again, the linear model is still not good enough. Okay, I think that's basically everything. I hope that clarifies things. If you have any further questions, please don't hesitate to send a post. You can post on this on the Discord channel. Okay, I hope that helped. Have a good day.